Hey, hi everyone. I am Gajanan More and I would like to welcome all of you to my YouTube channel. This is the first video which I am preparing for the YouTube, and the topic of the video is BPT, Basic Proportionality Theorem. First of all, we will discuss the statement of the theorem. What is the statement of the theorem? You know it very well. If a line passing through the triangle parallel to one side of a triangle, if a line passing through a triangle parallel to one side of a triangle, ABC is a triangle, and that line is passing through a triangle parallel to any one side. So I will draw it here like this. This line is passing through the triangle, and obviously this line seems to be parallel to the BC. So I am showing it parallel to the BC. If line is passing through the triangle parallel to one side of the triangle and intersecting remaining two sides in two distinct points, let those points be D and E. Why they are saying remaining two sides in two distinct points? Why they are simply not saying remaining two sides? Why it is necessary to tell two distinct points? Why it is necessary? Because if this is the triangle, this is the parallel line to the BC, A, B, C, it is parallel to the BC if I am drawing. Is this line passing through the AB? Obviously, it is passing through the AB as well as it is passing through the BC. Means it is intersecting both the sides, but in one point. And in this way, we cannot show that their ratios are equal or they are in proportion. Can we show? No. That's why what is necessary, beta? Here, it is necessary to tell it intersects them in two distinct points. Chalo, what happen if a line is parallel to the one side of the triangle and intersecting remaining two sides in two distinct points? What happen if such line is passing through the triangle? What it does to that triangle? So it makes the ratios of the intersected sides equal. It divides them in proportion. If the line is passing, then AD upon DB is equal to AE upon EC. The passing line divides the intersected sides into the proportion if it is parallel to the third side. This is all about the BPT statement. Statement is quite easy to understand. It is not hard. It is easy to prove as well. It is not hard theorem. So I just want you to understand this thing before we go through the BPT theorem. See here, in triangle ABC, I will take one more line here as a D. If we are looking at triangle ABD and ADC. Two different triangles are there. If we are looking at them, this is the one and this is the another. If we are looking at them, what is common in between them? You can say AD side is common, or as a vertex A and vertex D are common in between them. Obviously, right? What if I draw a height to the triangle ABD from the point D? So it will be falling on AB. The same thing I have done with that triangle, then it will be falling on AC. Means we are getting two different heights as per the D. But what if I gone through the A? A is also the common vertex. So if I drew height through the A, it will be falling on ABD. At this point E I will write here. And in this triangle, again if I drew a height or if I draw a height, then it will be again falling on E. Because on one side, on one line, from one point, we can draw only one perpendicular. And this is the perpendicular which we are drawing, AE. Right? If any two triangles are having common vertex, any two triangles are having common vertex, as per the vertex, if the bases are collinear, their heights are going to be equal. This is what I want you to understand. One more example I will give you, so better you can understand it. Here there are two triangles A, B, C, D. Two triangles ABD and DBC. Actually three triangles are there, but we will consider these two triangles. What is common in between them? One is the B, another is these two vertices are common. As per the B, what will be the base of the upper triangle? AD. And as per the B, what will be the base of lower triangle? CD. AD and CD, are they collinear? No, they are not collinear, so we must have the different heights, right? But if we considered D as a common vertex, what will happen then? If we consider D as a common vertex, it will be the height, whatever is I will take one vertex here, DE is the height, right? If DE is the height, that DE is the height for this triangle as well as for this triangle. Even if I want to draw height for this triangle ABD from D, the same line will be drawn. Why it is happening? Because this is the common vertex and bases are collinear. If any two triangle, any number of triangles are having common vertex and their bases are collinear, their heights must be same. Example here. A, B, C, and here it is D. I will take D slightly to the another side. D. In these two triangles, A and D are the common vertices, but due to the D, we are going to get the two different heights. So we are not considering D as a common. As per A, we are going to get the same height. I will draw the height as well. Chalo. Now, area of triangle ABE ratio we are writing, area of triangle ADC is equals to, what is the area of triangle ABE? Half into base BD. ABE I am writing, I am supposed to write ABD as we are considering ABD triangle. So what is the base of ABD? BD. What is the height of ABD? AE. Similarly, half into, what is the base of ADC? DC. What is the height of it? AE and half will get cancelled. If the triangles with the equal height, their ratio of their corresponding, the ratio of their areas is equals to the ratio of their corresponding bases, that is BD upon DC. When we can write it like this, if their heights are equal. Over. Now we will go through the theorem now. What we want to prove. Here in this one, what is given to us? A line is parallel to the side. Line is parallel to the side. I will draw our final diagram here. A, B, C, and line is passing, line L is passing through the triangle and intersecting this triangle at point P and Q. Right? What we want to prove here then? We want to prove AP by PB is equals to AQ by QC. But what is given? This line is parallel to, this is the only thing is given to us. So here I can write, from here I will start, given line L is, line L is parallel to the side BC. This is what is given to us. Then what we are going to do with it? What we want to prove? To prove. What we want to prove? AP by PB is equals to AQ by QC. We want to prove AP by PB, AQ by QC. So, what is the necessary construction? Now look at the board. Here, as you can see, we want to find the ratio. First of all, if you observe your target, what is our target? AP by PB is equals to AQ by QC. AP is the part of triangle APQ, we can understand. PB is not the part of any triangle. And even if we want to include both of them into the target, then we have to join this segment. So I join the segment BQ. What will happen? I will tell you. Now you are looking at the triangle APQ and BPQ. Both the triangles you are looking at. What is common in between them? You can tell me. What is common? So P and Q points are common in between them. So opposite to which common vertex the bases are collinear? You can see and tell me. Opposite to the P, AQ and BQ. Are they collinear? They are not collinear. Opposite to the Q, AP and PB. When we made this construction, we got these two bases as a collinear, and this is their opposite vertex. So we can say in triangle APQ and BPQ, vertex Q is the common vertex and their bases are collinear. So what will happen? Their heights are going to be equal. If heights are equal, then ratio of areas is equals to the ratio of their corresponding bases. This is why we have to join them together. Over. Now let me write down. Construction, join BQ. As well as we need to join CP. Why? I will tell you later on. BQ and CP. Over. Now, as we have discussed it. So first of all, in which triangle? In a triangle APQ and BPQ. APQ and triangle BPQ. In a triangle APQ and BPQ, what you know? In a triangle APQ and BPQ, Q is the common vertex. What is Q? Q is the common vertex and their bases are collinear. If you write this statement, you don't have to make this kind of construction perpendicular. No, you don't have to do this. Right? That's why I am explaining all those things to you. So here collinear. Then directly what can I write? Area of triangle, ratios of their areas. Area of triangle APQ by area of triangle BPQ. As per this statement, their heights are equal. Then what is the base as per the common vertex Q? As per the Q, AP is the one base. As per the Q, BP is the another base. So here I can directly write AP upon PB. It is number one. And what is the reason? Here triangles with equal height. Triangles with equal height. This is the first statement we got now. We targeted to our target and we found LHS of the target is here. What is the RHS of the target? AQ upon QC. If you observe, AQ is the part of APQ with the base P. If we considered QC is also the part of triangle, but in which that P is not included. But if we join CP, then they will be having the common vertex and their bases will be collinear. To have the common vertex and collinear bases, we join CP, which we already write here. What we write, beta? Where is it? Join CP. Already we joined. Okay? Now, so similarly we can write about APQ and CPQ as well. But what is going to be common in APQ and CPQ? You can look at it. APQ, CPQ, P and Q are common. As per the Q, bases are not same in APQ and heights are not same in APQ and CPQ. But as per P, bases are collinear. So heights are going to be equal or same. Okay? So here again I can write in a triangle. In which triangle I have to write now? APQ and triangle CPQ. Which is the common vertex now? Tell me. P is the common vertex and their bases are collinear. So what can I write? Will you tell me, beta? APQ, area of triangle APQ by area of triangle CPQ. Now we are comparing with the CPQ, which is equal to corresponding bases APQ and CPQ. AQ upon QC. What is the reason? Triangles with same height. This is the number 1, this is the number 2. We got it. What we got? We got the LHS, then we got the RHS as well. But what is the relation between LHS and RHS? They are equal. Now we are comparing them. If we compare 1 and 2, we can see numerators are equal. APQ and APQ, both the triangles are same, right? We don't know about BPQ and CPQ. We don't know about BPQ and CPQ. So we have to compare them. Where is the BPQ? You can tell me. Here is the BPQ. This is the BPQ. BPQ. Its vertices you can see. If I draw a height from B, it will be the distance between two parallel lines, minimum distance between two parallel lines. And in CPQ also I can observe it will be the distance. Even the heights are different, but the distance is same. The distance, minimum distance between two parallel lines is always same. And that's why we can say triangles which lies between two parallel lines having the equal height. Their heights are equal. Acha, now look at the board. Consider this triangle. Which one? BPQ. In BPQ, if I am drawing height from B, then it is falling on PQ. And in CPQ, if I am drawing height from C, then again it is falling on PQ. These are the heights which are same and base is common. Means height and bases, both of them are same. Means their ratios is equals to 1. Height is going to get cancelled because they are equal. Base is also going to get cancelled. So what will remain? Only 1 will remain. So here I can write at last, in a triangle, in which triangle? Simply triangle BPQ and triangle CPQ lies between two parallel lines and their base is common. I can write here PQ for our understanding. So what I can write with the help of this? Area of triangle BPQ by area of triangle CPQ is equals to 1. This is number 3. Okay. So what is the reason? triangles with equal heights and common base, their ratio is 1. Whose ratio is equals to 1? 3 by 3 ratio is 1. 4 by 4, 100 by 100, 1000 by 1000. The numbers which are same, their ratio is equals to 1, means they are equal to each other. Area of triangle BPQ, simply you can send it to the right and write area of triangle CPQ, which is number 4. We compared numerators and we found them equal. Now we compare denominators and they are also equal. What 1 and 2 are telling? Numerators are equal. What is 4 is telling you about? Denominators are also equal. Means these two ratios are equal. So their corresponding values are also be equal to each other. So I can write here from 1, 2 and 4. What can I write? From 1, 2 and 4. I can write area of triangle APQ by area of triangle BPQ is equals to area of triangle APQ by area of triangle CPQ. That's it. Okay? And here you can write it as a number 5. They are equal, right? Acha. 1 and 2, now 5 is there. From 1 to 5, what we can write? If they are equal, their corresponding values are also equal. I will write my last statement here due to the lack of space. So, from 1, 2 and 5, what can I write, beta? APQ, BPQ, their corresponding values are this one. As they are equal, their corresponding values are also equal. Therefore, AP by PQ is equals to AP by PB is equals to AQ by QC. This is how we can prove the basic proportionality theorem. It is not that hard. It is easy, but you have to try to solve this theorem by your own once or twice, and you have to understand why the vertex Q is common in the first one. If you are taking this one as a common, bases are collinear. If you are taking this one as a common, bases are collinear. As they are lying between the two parallel lines, their heights are equal. If the heights are equal, both the heights are falling on the same base. And that's why base is also common. That's why they are also equal to each other. And this is how we can prove the basic proportionality theorem. Dear students, if you like this video, then subscribe this channel and also hit the bell icon. And if you want me to explain any other theorem, then you can write it into the comment box. Thank you everyone.